Good day. So for today, I will going to report about synthetic division. Brief history of synthetic division. This method was invented by Paolo Ruffini. He took part in a competition organized by the Italian Scientific Society. The questions to be answered was a method to find the roots of any polynomial. 5 submissions were received. In 1804, Ruffini was awarded the first place and the method was published. Ruffini published refinements of the method in 1807 and 1813. Synthetic division is a method used to facilitate dividing a polynomial f of x by a linear polynomial of the form x minus r. It is a method for manually performing Euclidean divisions of polynomials, with less writing and fewer calculations than polynomial long division. Scientific division or synthetic division for linear denominator is also called division through Ruffini's rule. Advantages in using synthetic division. It allows one to calculate without writing variables. It uses few calculations, and it takes significantly less space on paper than long division. Also, the subtractions in long divisions are converted to addition by switching the sign in the very beginning, preventing sign errors. So, by this given equation here, or example equation here, we are able to visualize what is synthetic division. So first step, write the terms of the dividend in descending power of x. Insert a zero coefficient for every missing term. For this equation, 3x4 minus 5x3 plus x squared minus 9x plus 16, write the term without variables. So 3x4 to 3, negative 5x cubed to negative 5, x squared to 1, 9x to negative 9, 16 to 16. Second step, write the coefficients of the dividend and the value of r on the first row. So our dividend here is x minus 2. So in second step, we need only to write the value of r, which is positive 2. Third step, bring down 3, which is the r leading coefficient. Fourth step, multiply 3, our leading coefficient, by 2, which is the value of our r, and add this to the product to the next coefficients of the dividend and repeat the step for each coefficient. So, the product of our first coefficient 3 and our dividend 2 is positive 6. Then add this to our negative 5, which is our second coefficient. So, it will be the sum is positive 1, and repeat the step until to the last coefficient. So fifth or last step, the last number in the third row is the remainder, and the preceding number are the coefficient of the quotient. So in this third row, the last number is positive 10. That will serve as our remainder. In this given equation, 3x4 minus 5x cubed plus x squared minus 9x plus 16 divided by x minus 2, our quotient will be 3x cubed plus x squared plus 3x minus 3 plus 10 over x minus 2. So this second example, we're going to visualize it clearly by this equation, solving equation. 2x cubed minus 13x squared plus 17x minus 10 by x minus 5. So, write the term in this coefficient 2x in this equation. 2x cubed minus 13x squared plus 17x minus 10. So, the solution will be 2 minus 13, 17, and negative 10. And the second step was to write the dividend the x minus r. Write only the r, the value of r. So the solution will be positive 5. So the third step was to bring down the first coefficient, which is 2. And the fourth step was to divide, or the multiply rather, the leading coefficient here, multiply the positive 2 to our dividend, which is 5. So positive 2 multiply positive 5 equals 10. Then subtract or add that 10 to our second coefficient, which is negative 13. So the sum will be negative 3. And negative 3 multiplied by positive 5, the product will be negative 15. And add this negative product to our third coefficient, which is 17. So the sum will be positive 2. So positive 2 multiplied by positive 5. So the product will be positive 10. This product of 2 and 5 will be added to our last coefficient, which is negative 10. So negative 10 plus 10 equals 0. Thus, 2x cubed minus 13x squared plus 17x minus 10 divided by x minus 5 equals 2x squared minus x minus 3x plus 2. This 2x squared minus 3x plus 2 is our quotient of this given equation. So exercises. And that will be, thank you.